Hello guys, welcome to Study Heroes. In this video, we're looking at grade 12 analytical geometry. We'll be focusing on the section whereby they give you a circle with a triangle and lines. So the question we'll be looking at is from November 2024 NSC question 4 paper 2. Question 4 reads as follows. In the diagram, M, here is point M, is the center of the circle, and the circle cuts the x-axis at N. ST is a tangent to the circle at P, and they've given us the point P. They're telling us that point R has got, so they didn't give us the exact x value of point R. They gave it as D, and they're telling us that D is greater than 0, and L lie on the circle. So point R and point L, they lie on the circle. They are points on the circle. O and V are the x-intercepts of PL and RL. So it's always good to read the information that you have been given. 4.1 says, write down the coordinates of L. So L is this point, and L is on line PL. So if you look at line PL, you know that you've already been given the midpoint. So you can use the midpoint to find the coordinates of L. If we were looking for the midpoint, we were simply gonna take the x value of L and the x value of P, add them together and divide by 2. That was going to give us the x value of the midpoint. And then to find the y value of the midpoint, we're going to take the y value of point L, add it with the y value of point P, divided by 0. But in this case, we already have the midpoint. We are just looking for the x value of L and the y value of L. So what we're going to do, we're going to say the x value of the midpoint, or the x value of M, is equals to the x value of L plus the x value of P, and then we divide it by 2. And the same thing, the y value of M is equals to the y value of L plus the y value of P, and we divide everything by 2. What is the x value of M? The x value of M is 1, so we can substitute 1 equals to the x value of point L is what we are looking for. What is the x value of P? It's 3. So we have 3 all over 2. All right. And then, okay, let me just write and here and here. Okay. So the y value of the midpoint is 3. Equals to the y value of L is what we're looking for. The y value of point P is 9, and we divide everything by 2. Therefore, we can multiply this 2 with that 1. We end up with 2, which equals to x of point L plus 3. And then we know that to find L, we're going to take 3 to the other side. It's going to be 2 minus 3. So XL is going to be equals to 2 minus 3. which is 2 minus 3 is negative 1. And then we multiply this 3 with 2, we're going to end up with 6, which equals to YL plus 9. Therefore, YL is going to be equals to 6. We take the 9 to the other side, it will be minus 9. 6 minus 9 is going to be equals to negative 3. So this means that the coordinates of L are negative 1 and negative 3. So we're done with 4.1. We can go to 4.2. 4.2 says determine the equation of tangent ST to the circle at P. So they want us to find the equation of this line. But in order to find the equation of this line, we need the gradient of this line. And to find the gradient, we need at least 2 points. So we've only been given 1 point, so we can't find the gradient with this point only. But you need to remember that if line 1 is perpendicular to line 2, then the gradient of line 1, when you multiply it with the gradient of line 2, you're gonna get negative 1. So this is something that we know about perpendicular lines, and it will help us here because this line is the radius of a circle. So what is the radius of a circle? Any line that goes from the center of the circle to the circumference of the circle is the radius. So in this case, this line is the radius. Line MP or PM is the radius. So this line, because it's meeting the tangent here, we know that this line is perpendicular to the tangent. Why am I saying this? The tangent and the radius of a circle are always perpendicular to each other. So they will always meet at 90 degrees. So whenever you have a radius and the tangent meeting, then you can assume that the product of their gradients will give you negative 1. This means that we can focus now on line PM, which is the radius. And because we have 2 points on line PM, then we can find the gradient of line PM. So 4.2, we can find the gradient of line PM. We're gonna take the y value. So I'm gonna start off by P. You can start off by M, it's up to you, as long as you make sure that whatever you start with, if you start with the y value of P, then you must start with the x value of P. If you start with the y value of M, you must start with the x value of M. So just make sure that your coordinates are corresponding. So now I'm gonna have the y value of P, gonna subtract the y value of M, and I am gonna have the x value of P, and I'm gonna subtract the x value of M. So this will be y of P is 9 minus the y value of M is 3 all over x value of P is 3 minus x value of M, which is 1. So this will give us 9 minus 3 is 6 all over 3 minus 1 is 2, and this is the gradient of PM, it's equals to 6 divided by 2 is positive 3. So we have the gradient of line PM. So now we can use the gradient of line PM because line PM is the radius. We can use the gradient of line PM to get the gradient of line ST. This is what we're gonna do. We're gonna say the gradient of line ST. So we're looking for the gradient of line ST. So we're gonna say the gradient of line ST, when we multiply it with the gradient of PM, must give us -1. You remember, it's what I was talking about when I said the two lines are perpendicular to each other. So now from here, then we can work out the gradient of ST. PM is 3 equals to -1. So we're just going to divide by 3. Then the gradient of line ST is going to be equals to -1 divided by 3. So we have the gradient of line ST. So now that we have the gradient of line ST, we just need one point on the line, which is point P. They've given it to us. So they've given us that point P they've given us the x value to be 3 and the y value to be 9. So to find the equation of line ST, all we're going to do, we're going to use y minus y1 equals to m into x minus x1. We're going to say y minus, then we substitute the y value on the line ST, and it's 9, which equals to the gradient. We found it to be -1/3, and we're going to have x minus, we substitute the x value of a point on line ST, which is 3. And then we're going to have y equals to -1/3. We're going to take -1/3, multiply it with this x. We're going to have -1/3 x. Then we're going to have -1/3 multiplied by -3. So the negative times negative will give us a positive. And then we're going to have 1/3 multiplied by 3. It will be 3/3, which is 1. And then you bring the 9 on this side, and it will change the sign to become positive. It'll be positive 9. So therefore, y is going to be equals to -1/3 x plus 10. So we found the equation of the tangent. So now we can go to the next question. 4.3 reads as follows. It says, show that the equation of the circle with center M is x squared plus y squared minus 2x minus 6y minus 30 equals to 0. So they want us to show that the equation of this circle is that. So to find this equation of the circle, the center radius equation form of a circle is x minus a squared plus y minus b squared equals to r squared, where a is the x value of the center and b is the y value of the center. All right, so what we're gonna do, if we look at the equation they want us to get to, you realize that there is no r here. So it means that they already worked out the radius. So we're going to first start off by finding the r squared. In order to find r squared, we're going to use this equation by substituting 1 point on the circle, and the point we've been given is point P. So we are going to substitute point P, which is this, and we're also going to substitute the center, which is this. So x value of a point, we'll use point P, where x is 3, minus x value of the center of the circle. We have the coordinate of the center of the circle, so the x value is 1, squared, plus y value of a point on the circle is 9, minus y value of the center, which is 3, squared, it equals to r squared. So 3 minus 1 is going to be 2. 2 squared will give us 4, plus 9 minus 3 is 6. 6 squared will give us 36, which equals to r squared. 4 plus 36 will give us 40. So therefore, r squared is going to be equals to 40. So we're going to use this again. Now that we have r squared, we're going to take this equation and we're going to put the center again, and we're going to put r squared, and then from there we simplify and make sure that we end up with the equation of the circle that they want us to have. So x, we're going to have x minus a, we substitute the x value of the center, squared, plus y minus, for b, we're going to put the y value of the center, squared, equals to r squared. We now know that it is 40. And then from here, we are gonna expand the brackets and simplify. So x minus 1 squared, we know that that means you have 2 brackets, which is x minus 1, x minus 1. So x times x will give you x squared. X times negative 1 will give you negative x. Negative 1 times x, you'll get another negative x. Negative times negative will be positive. 1 times 1 is 1. So you end up with x squared, and then negative x and negative x, because the signs are the same, you're gonna add and you're gonna have 2x, and then you're gonna take the sign, which is negative plus 1. So when you simplify that, you end up with x squared minus 2x plus 1. Then we can simplify this one, y minus 3 squared. We know it means it's 2 brackets, y minus 3 and y minus 3. So we're going to say y times y, which will give us y squared. Y times minus 3 is going to be minus 3y. Minus 3 times y will give us another minus 3y. Negative times negative is a positive. 3 times 3 is 9. So we're going to end up with y squared. We add the like terms. we have minus 3y and minus 3y. Because the sign is the same, we add 3 plus 3 will give us 6. Because it's y, it'll give us 6y, and then we take their sign, which is a negative, plus 9. So it means this can be simplified to be y squared minus 6y plus 9, and then we can bring this 40 this side, it'll be negative 40 equals to 0. So from here, we are working towards arriving to this equation. So as you see, they've grouped x squared with y squared, and they followed by x, and they followed by y, and then the constant. So this is what we're going to do. We're going to follow that order. So we have x squared, then we can bring y squared. So just to make sure that we get everything. Okay, so we have y squared, x squared, and then we'll have 2x. So we'll have minus 2x, and then we'll have our y minus 6y. So we dealt with that, we've dealt with that, then we are left with the numbers. So we have 1 and 9, which will give us positive 10. Positive 10 minus 40, we're going to have minus 30 equals to 0. Now this is the same as this. So we have proven that indeed this is the equation of the circle. So we can go to the next question. 4.4 says, show that D is equal to 7. So D is the x-coordinate of point R. So they want us to find it and show that it is 7. So how can we do it? So this equation, we're going to use it by substituting 1. So we can end up solving for D, the x value of R. So the equation of the circle is here. It's x squared plus y squared minus 2x minus 6y minus 30 equals to 0. Then we're going to substitute so the y value to be 1, and we know that x is D. So instead of writing x, we'll write D because we want to solve for D. So it'll be D squared plus, instead of y, we're going to put 1, and then we're going to have 2D minus 6. Y is 1 minus 30, which equals to 0. So we're going to have D squared minus 2D. Then we'll have positive 1 and minus 6, which will give us minus 5. Minus 5 minus 30 is going to give us minus 35, which equals to 0. So now we have a trinomial which we can factorize. To get D squared, we must put one D here and another D here, so that D times D can give us D squared. To get 35, we must have two numbers that we can multiply to give us 35, and that is 5 and 7. 5 times 7 will give us 35. Because our 35 is negative, it means the 5 and 7 will have different signs. One of them must be positive and then the other must be negative. So to know which one will be negative, which one will be positive, we'll look at the middle term. The middle term is negative, which means that the bigger number must take the negative sign. And then the other one will get the positive sign. If we say minus 7 plus 5, then we'll be able to get minus 2. So we're on the right track. So D is going to be equals to negative 5, or D is going to be equals to positive 7. Now you must, okay, so when you look at this, already you can see that point R is on the positive side of the x-axis, meaning D is supposed to be positive. But also, they also told us that D must be greater than 0, meaning D, the x value of R, has to be positive. So we are gonna say, but D is greater than 0. So therefore, we have proven that indeed D is 7. Then we can go to the next question. 4.5 says to us, calculate the size of angle L. So let's look at this angle L. So angle L is this angle. So you start off by drawing the horizontal line, and then you will see that, okay, this line LR forms an angle, which is this one, and then the yellow line with the horizontal line also forms another angle. And these two angles can help us get the angle we are looking for, which is this one. So if we take the angle formed by the horizontal and line LM, this is called the angle of inclination formed by line LM. If we take it and we minus the angle of inclination formed by line LR, then we're gonna find angle L. 4.5. We know that in order for us to find angle L, we must take the angle of inclination of line LM, and we must minus the angle of inclination of LR. Now, how do we find the angle of inclination? We know that it's M equals to tan theta, and then theta, the angle of inclination, will equals to arctan, the gradient. So it means that we need the gradient of LM and we need the gradient of LR. So what is the gradient of LM? LM is on the same line as PM, and we already found the gradient of PM when in the previous questions. So in 4.2 we found out that the gradient of PM is 3. Therefore, because PM and LM are the same line, the gradient of LM is the gradient of PM, which is 3. All right, so from this we can find the angle of inclination of LM. It will simply be equals to arctan 3. Yeah. So when you work this out, you just press shift tan 3. Then you'll get a value. But we'll leave it at this so that we don't find ourselves rounding up prematurely and end up having an answer that is a bit off. So we'll leave it like this for now. And then we need the gradient of LR so that we can find the angle of inclination of LR. So let me just write that this is for LM. So now we need the gradient of LR. We can calculate the gradient of LR because we've already found the x value of R to be 7. We've already found the coordinates of L in the first question to be -1 and -3. So we can then take the y value, I'll use of R and minus of L, and then I'll take the x value of R, I'll minus the x value of L, which will give us the y value of R is 1 minus the y value of L, which is -3, all over the x value of R, which is +7, minus the x value of L, which is -1. It's equals to 1 negative times negative will be positive. So it will be 1 plus 3, which will be 4, all over 7. Negative times negative will be positive, so we'll have 7 plus 1, which is 8. So we end up with half, because 4 into 4 it goes once, 4 into 8 it goes 2 times. So we have the gradient of LR, and from there we can find the angle of inclination of LR to be shift tan of a half. So angle L is gonna be equals to, we're gonna substitute the angle of inclination of LM, which is tan, it's shift tan 3. So we're gonna have shift tan 3 minus the angle of inclination of LR, which is shift tan half. If you press this in a calculator, you should get 45. So the angle L is equals to 45 degrees. The last question we have is 4.6. It says TR. TR is a tangent to the circle at R. So let's look at TR. TR is that. So let's try to draw TR. Alright, so that's TR. And they're telling us that TR is a tangent to the circle. Okay, what else? At R, and they want us to prove that PT is perpendicular to RT. You see how here they're saying RT, but in the beginning they said TR. So TR and RT is the same line. TR and RT, it's the same line. So don't be confused by that. I'm gonna mark PT with a green line. So PT is here. Okay, so they want us to prove that these two lines are perpendicular, which means that they meet at 90 degrees. So they want us to prove that. I want you to remember this. We said if two lines, line 1 and line 2, are perpendicular to each other, then the product of their gradients must be -1. When we multiply their gradients, we must get -1. So it means that if these two lines are perpendicular to each other, all we need to do to prove that they are perpendicular is to simply get their gradients, multiply them with each other, and get -1. Which means we just need the gradient of each line. So with line PT, we can easily find the gradient of line PT because the gradient of line PT is equals to the gradient of line ST. Because PT and ST are collinear. They are on the same line, so the gradient is the same. And in the earlier questions, we worked out the gradient of ST to be -1/3. So now all we need is the gradient of TR. But we are gonna have to work a bit to find it because we don't have 2 points. But now I want you to remember what we said about the radius. Remember what we said about the line that goes from the middle or the center of the line to the tangent. So they said RT is the tangent, meaning then that RT is perpendicular to the radius. So we have the coordinates of the center of the circle, which is point M, and we have the coordinates of point R. So we can find the gradient of line MR, which is the radius. So let's find the gradient of line MR. So we are looking for the gradient of line MR. We are gonna use the y value of point R minus the y value of point M all over the x value of point R minus the x value of point M. And this is equals to yr is 1 minus y of M is 3 all over xr is 7. We worked it out. And xm is 1. So another tip, as you're busy solving your questions, do fill in the missing information that you're discovering along the way, so that as you work out other questions, you don't find yourself being confused. Like here, if you forgot that we already worked out D, you might feel stuck. So it's good to put in the information that you have. We're gonna have 1 minus 3 is gonna give us -2 all over 7 minus 1 will give us 6. And this will be equals to 1 over 3. Negative. So we found the gradient of line MR. What we know is that the gradient of line MR, when we multiply it with the gradient of line RT, our answer must be -1 because they are perpendicular to each other. How do we know that? The rule is that the radius of a circle is perpendicular to the tangent of that circle. All right, so we found the gradient of MR to be -1 over 3. We don't have the gradient of RT. It's equals to -1. And to find RT, we can divide by negative, or we can simply multiply everything by -3. Then we're going to end up with +3 because it's going to be -1 times -3 will give you +3. Here we're going to have -3 times -1 over 3. The 3's will cancel, so you end up with +1 and times MRT. So you end up with this. So now, we're not done, but the wonderful thing is that we have found the gradient of RT and we also have the gradient of PT. So we are still proving that they are perpendicular. So to prove that they are perpendicular, we're going to take the gradient of PT, we're going to take the gradient of RT, and we're going to multiply them and prove that indeed they are equal to -1. And if they are -1, then we have proven that they are perpendicular. So the gradient of PT, we worked it out to be -1 over 3. -1 over 3 multiply by the gradient of RT, we found it to be +3. So this 3 will cancel with that 3. We're going to be left with -1. So therefore we have proven that PT is perpendicular to RT. Thank you for joining. Please don't forget to like, comment, subscribe. It will help the channel to grow and reach other students who also need help. Thank you. Bye.